Good morning, everyone. My topic is exploring the constellation, enabling IoT connectivity through satellite communication. Uh, Basically, my work is on 5G satellite integration, satellite aids computing, and I am starting to work on IoT satellite communication in the IoT. That one project I got there I am introduced to the IoT, how the satellite will help in the IoT communication. Before that, I want to give an introduction of the for the audiences. Those are my table of contents. First is I'll tell this is the audiences who don't know, who are unaware of what is satellite constellation, and I will give basic introduction of IoT, then satellite-based IoT, and what we are doing in IEEE satellite working group. That mostly all the work that is basically for the IoT, that is for satellite working group. It is like integration of 5G, 6G, and IoT, those things. I will discuss about those. The artificial satellite and its orbit. I think many of us.
Deva sir, that shall be wonderful if you can introduce us to the 5G and 6G also, because 6G is, into the things these days. Whatever you can explain during this lecture.
Yeah. Towards the end, I have put some slides, 1 or 2 slides about 6G.
Okay.
What basically what we are doing in that working group. I'll give an introduction about those things. What is a definition of artificial satellites and its orbit? Like a satellite is simple, any body that moves around another larger body, like in this case Earth, in the mathematical predicted path. It's called orbit. So there are different type of orbits are there. That is low Earth orbit, medium Earth orbit, geostationary orbit. Those things I will discuss later. Sun synchronous orbit, polar orbit, geostationary transfer orbit, highly elliptical orbit, and very low Earth orbits. So before that, I want to just show a video for a satellite launch. This is a geo satellite launch, geostationary satellite launch. I think my video is not working in the slide. I'll just show it.
Does it has even sound with it?
Yes, it has sound. It's not audible.
No.
So it is just music. I can narrate.
Okay. Perfectly fine. Please play.
This is a British company who has built a geo satellite constellation that I will discuss later. So their GX5 is the geo satellite which they are sending to the orbit, and how it is actually done. There are multiple rocket stages are there. So this is after three. This is the last stage of the rocket where it will put the satellite in the orbit. That is it will put in orbit in nearby Earth. So then by booster it will send to the geostationary orbit. So there you can see the solar cell, deployment of solar cell, then the deployment of antenna. Then it will start communicating with the Earth. This is the basic idea of how the satellite is being launched and is deployed in the orbit. Geostationary orbit is 35,786 kilometers, around 36,000 kilometers above the Earth. And in this satellite, they are providing high speed broadband service to the Europe and the Middle East. Mostly it is British based company, that's why. And for India also, we have sent multiple geostationary satellites where broadband internet, then Earth observation, those things are done. Those are the Earth station, so which will communicate with the geo satellite. And actually, as the distance is very high of a geostationary satellite, so the antenna will be very big, and usually our usual equipment like mobile phone cannot connect. They don't have that much higher antenna gain. So this is the how the satellite being sent. Then when you are designing a satellite, so there are some 6 parameter of a orbit. When you are designing a satellite, which orbit you are going to send the satellite, there are 6 parameter we call Keplerian orbital parameters. One is semi-major axis. As you know that satellite will satellite will be moving around a elliptical orbit around the Earth. So, and in that elliptical orbit, semi-major axis is one of the parameter. First, we have to determine the semi-major axis. Then the eccentricity. Eccentricity means if how elliptical it is, whether it is circular or elliptical orbit. Then the inclination angle. Inclination angle is the angle between the equatorial plane. This is equatorial. We know Earth has equatorial plane. That we take as a reference point. Reference plane. Then from that, which angle the satellite orbit will be the satellite orbit will be there. That is called the inclination angle. And the inclination angle can be actually two satellite planes can have can have same inclination angle. So so for that there are some other parameter to determine the which orbit the satellite will move. Another is argument of perigee. Argument of perigee is like in the in a elliptical orbit, so there will be 2 points. One will be near to the focal point, another is the far away from the focal point. So that is the near to the focal point we call perigee. Far away from the focal point we call apogee. Now the argument of perigee is the angle between that this point ascending where the interaction point of the orbital plane and the reference plane, that is equatorial plane. From that the from there to the perigee point, that is the angle that is called argument of perigee. Then right ascension of the ascending node, that is the angle between vernal equinox and the ascending node. Vernal equinox is the similar like x y z axis. Earth has x y and z axis. So at the reference point is the equatorial plane. So that will be x and y axis, and pole will be the z axis. So in that way, you can see that vernal equinox, angle between vernal equinox and the ascending node. That is the run. We call run. Then mean anomaly. Mean anomaly is the point, satellite position, exact satellite position in the orbit. So that is called the mean anomaly. By using six parameter, we usually determine the satellite orbit. Before sending the satellite, we have to know which in which orbit satellite will move. The next is LEO satellite. Basically, I will mostly in this presentation I will focus on LEO satellite. So I am telling what is the LEO satellite. LEO satellite is it is the or the altitude will be around 500 to 1500 kilometer from the Earth. So in that range, the satellite the orbits of satellite in that range is called LEO satellites. So as it is near to the Earth, so the satellite moving around 7.5 kilometer per second, which is so fast, and the the sight of the satellite, it will be 5 minutes, like 5 minutes to 10 minutes. That depend on the which altitude satellite is. Shortest distance from Earth compared to the other orbits. Yeah, that's true. Satellite in these orbits have orbital period around 90 to 100 minutes. For satellite, one revolution of the satellite, it took 90 minutes, around 90 minutes or 110 minutes. So in a day, in multiple times it will pass. Multiple times or single time, that depend on, because the Earth is moving around it and moving around herself, then the satellite will move. So in that way, so sometimes it might pass, sometimes it will not pass in the same location. I'm talking about same location, but it will pass through multiple location. These characteristics make that is the LEO satellite characteristic. And other different orbits are GTO, called geo transfer orbit. When you are sending a geo satellite, like before one video I saw, they are sending a geo satellite. When you are sending a geo satellite is around 36,000 kilometer away, 36,000 kilometer altitude. to send the satellite to that orbit, so much fuel is needed. So to avoid that fuel, first they will put in a LEO orbit. You can see that here. Then LEO orbit first they will put. Then can you see my pointer? So then they will
Yes, sir, it is visible.
yeah, then they will use thruster here at this point. After that, so so the satellite will go in a highly elliptical orbit. Uh, after achieving the highly elliptical orbit at this point, then they will start thruster in this point, so that slowly it will make a circular orbit, and that is called the geostationary orbit. And that's how the geostationary satellite being sent. Now, the speciality of geosatellite is that rotational velocity of Earth and velocity of the geostationary satellite is same. So that when it is stationary to the user, if you are seeing a geostationary satellite, it will always that same location. It will look like a same location. Um, so that is the geo satellite. Then we called MEO satellite, medium Earth, which is around 5,000 kilometer to the 2,000 kilometer altitude. Those satellites as the medium Earth. Another is called sun synchronous orbit. It is one type of a LEO, and sun synchronous orbit means a satellite will be the satellite will launch in a orbit in that way that, for example, if I am in Trivandrum at 6 o'clock, I saw a satellite. So after 24 hours, the same satellite will pass at same time. So that is called sun synchronous time, sun synchronous orbit, and uh, uh, so it will take 24 hours to reach at same place. It as it is a Leo orbit, it will pass multiple times in on different location. But for the same location, it will take 24 hours. That is called sun synchronous orbit. After different time, this is the comparison like the Leo, MEO, and GEO. Satellite cost. This is actually for a single satellite. It's very low. Cost is very low. This is for satellite constellation, which is very high. If you are a multiple, if you are sending thousands of satellites, then the cost will be high. In that way, this is the table. Then this is the MEO, medium, and GEO, medium. Satellite life, handheld terminal possible. Handheld terminal means through mobile phone we can communicate with LEO, MEO, but for GEO it is very difficult. Propagation delay is very short, medium, large. Propagation loss it is proportional to propagation delay only. Network complexity, then handoff very medium no. This handoff is very important when you are considering our LEO satellite constellation in IoT, because for geo satellite there will be no handoff, but but when a IoT device is connected to a LEO satellite, in 5 minutes that satellite will go, next satellite will come. So handoff is so much handoff is required to make a seamless connectivity. Development period, long visibility of satellite very short. I told 5 minutes, and for MEO it is like in hours, 2 to 6 hours. Then for GEO it is 24 hours. It will be available for a location. Uh, the next is satellite constellation. Satellite constellation is a group of group of satellite working together to achieve a specific purpose. Uh, then LEO satellite constellation, MEO satellite constellation, GEO satellite constellation. Uh, So you can see that there are multiple application through the LEO satellite constellation. One is Earth observation, one is telecommunication, then navigation like GPS, telecommunication like Starlink. You have heard of Starlink satellite constellation. Then next is scientific research. Satellite constellation design. We need to take care of actually satellite constellation design happen according to the requirement. It depend on why you are saying why you require satellite constellation or multiple satellites for which work, which service you want to deliver. In that way, the design can be different. Now, simplest design is the Walker Delta constellation. Walker constellation, which has two parts. One is Walker Delta and is Walker Star constellation. And there are, as you know, that the Kepler orbit has six variable, uh, s- six parameters. So that's why the larger optimization space of 6n variable for n satellite constellation is required. Then the Walker Delta, in the Walker Delta constellation, most satellite constellation they use Walker Delta. Walker Star, nobody use. In Walker Star, the inclination angle will be different, but Walker Delta inclination angle will be same, but the orbital plane will be different. So maybe in the 3D model you can see that, in the 2D it is not clearly visible. So in the Walker Delta constellation, there are mainly four parameters: the constellation inclination angle, the number of satellites, the total number of orbital planes, the relative spacing between satellite in a adjacent planes. Um, so what happens? Maybe I can. There is no diagram in the latter stage. One diagrams will come there. It will be more clearly visible that does this means. Basically when you are designing algorithm, constellation algorithm, first we will give those four parameters, then we will optimize that, like we'll give the minimum number of parameters, minimum of number of satellite, minimum of number of orbital planes, then minimum of number, then satellite, that minimum inclination angle. After that we will give the maximum also. In that, our it is a heuristic approach, so that it will test which is which is it will give multiple solution, optimization solution. So in that way, in that solutions, we have to check that which is perfect for our service. In that way we will decide a constellation. Then after that we will launch the satellites, number of satellites per plane. Uh, those are the, like, in a orbital plane means, yeah, I'll go here. Sorry. Yeah, this is the orbital. You can, if you are seeing the blue, this is called the orbital plane. So in that, multiple satellite will be there. Again, with the same inclination angle, there will be another orbital plane with same number of satellite. So that's what those parameters are telling. Then I will come to the geosatellite constellation. This is the one example that I have shown you the video. That is the GX5 year 2019. It is that geosatellite is being launched. So those whole satellite is called Inmarsat. So here there are 13 geosatellites and two highly elliptical GTO. It is in highly elliptical GTO, geotransfer orbit. So together this satellite, they create a network, highly dynamic network. We called orchestra. They call orchestra. What they do, that they do IoT service, then very remote area communication, and like flight, train, ship, then IoT application. Those things, the work of the constellation is in that way. And these two satellite, you are seeing that this is for the polar region. Like in the pole, there are so many scientific research are going on. So to provide internet to them, those two satellite are used for that, only for the pole. Then they are planning for multiple LEO satellite also to make a big network. Yeah. This is the first satellite constellation. There are multiple other satellite constellation there. Intelsat, E, Eutelsat. This is for Africa. The China sat is for China. Then Indian geosatellites are, like navigation with Indian constellation Navig. They use to 7 geosatellites to uh, uh, to uh, it will work like a GPS, but in the Indian subcontinent region for navigation. It is mostly for our defense. It is used to in our defense. Then for other satellite like GSAT 6, GSAT 11, INSAT 3D, INSAT 3DR, those are the geo satellites which use for the broadcast television, broadcast or broadband service in that way. Then the MEO satellite constellation, and this advantage in terms of coverage and latency compared to geo satellite. Obviously, the coverage will be less, but the latitude will be less. Propagation delay will be lesser than the geo satellite.
So
And
Debarat, this
yes,
constellation keep on changing based upon the location of the satellite, as we can see here in this.
yeah, this is for the this is the GPS. GPS GPS use
Means we get coverage from n number of people at a given moment of time based upon their location, and they keep on synchronizing. Yes.
yeah, that multiple
Okay. Okay. Okay.
multiple satellites will be there. There will be
Mm-hmm.
like in your phone there will be GPS receiver. So
Hmm.
if so multiple satellite will be sending signals to the GPS receiver.
Mm-hmm.
GPS receiver will be after receiving the signal,
Hmm.
it will calculate the distance between the satellite and receiver. So
Okay.
in that way it will compare with the whatever the satellite available at that time. Then
Hmm.
in that way
So
it
this
will,
constellation is not fixed. This keep on changing.
yeah, it is in it will keep on changing.
Yes.
And
Yes. Okay. Please continue. Yes.
yes, and this constellation design in that way that wherever you are in the earth, I think minimum four satellite will be there. I think I
Okay.
don't
Okay.
remember.
Okay.
In your phone there are
Means it will. They are synchronized in such a manner that they'll
uh,
provide that minimum coverage required.
yes.
Okay. Okay. Please
Only
continue.
yeah. So that is advanced in terms of coverage and like navigation. Mostly MEO is used for navigation and positioning systems. Examples are like here GPS. GLONASS is for GLONASS is used by uh, Russia. Then Galileo. Those there are different countries have different navigation system. Mostly it used for navigation and positioning. MEO satellite. Then and this is the sorry, this is the spelling mistake. This is the Leo satellite constellations. And Leo satellite constellation having many advantages like low latency, global coverage. For that, you need thousands of satellite for the global coverage. But after deploying all that, you can get a global like Starlink. Now Starlink has 3,900 satellites, where 3,400 are active and 500 are on the deployment stage. This is the Starlink satellite constellation. And it will look like from the space. It will look like this, and high bandwidth and capacity as it is as reduced signal power. As it is near to the Earth, like 1,100 kilometer altitude. Those satellites are average altitude, so that the signal power will be less. If the transmitter power in the transmitter power we can increase as the path loss is very less, and it provide high bandwidth and high capacity also. So the data rate will be very high for the Starlink. The applications are global internet coverage, earth orbit observations, real-time service. Like now, now people are talking about to satellite in 5G, satellite in 6G. For that we need real-time service. We need delay in milliseconds. So in that also applications are there. Then another application is IoT. Examples are SpaceX Starlink, which is shown in the figure. Then Iridium next, Iridium is the older version. Then Iridium next, which consists of 66 satellite, and in the latter I'll discuss OneWeb, Telesat, and Kuiper. Kuiper is for Amazon. Amazon is proposing a satellite constellation that is called Kuiper. Then I will talk about Internet of Things, and those are the definition of the internet. uh, like Internet of Things is a system of interrelated computing device. Those definition I think almost known to everyone. Device mechanical and digital machine objects, animals or people that are provided with unique identifiers and ability to transfer data over a network without requiring human to human and human to computer interaction. And mostly automate the things. A thing in the IoT can be person with a heart monitor. This is the example. A farm animal with a biochip transponder, or automobile that has built-in a sensor to alert the driver when the tire pressure is low, or any other natural or man-made object that can be assigned an IP address is able to transfer data over a network. So basically, we will collect the data from the sensor, and in the database we will analyze that, and we will send to the user. and the results will be sent to the user or alert the users. IoT is a sensor network, that is fine. Then those are the basic definition of IoT. And the futures of IoT is connectivity, analysis, sensing, active engagement, scalability, and AI. Those are the futures. AI, AI is implemented. It's not implemented fully. Then the
Mm.
components of IoT is sensor device, connectivity, data processing, and user interface. There are four things. And like I told, sensor will collect the data, uh, the and connectivity it will send the data to a data processing unit or a database. Then after analyzing, the result will be to send to the user interface. Challenges of IoT will be privacy. At you are privacy is the main concern, as we are not using standard or encryptions. Lack of knowledge, people don't know yet. And network connectivity and IoT sensors. They use Zigbee radio, which is the and Wi-Fi, which connectivity is
So,
very low. Range will be
why
very low.
Zigbee isn't LoRa good enough for these?
LoRa can be used. LoRa will be in the kilometers range. In the
Yes,
terrestrial
yes.
in the terrestrial case, it will be in the kilometers of range. That
Mm.
I discuss. LoRa has a very impact on the satellite IoT things. When that
Okay,
I'll
okay,
discuss.
okay,
So
okay, okay.
that's
Please.
and the reliability. The classifications of IoT protocols like applications layers have those protocols, transport layer, UDP, TCP. This is the terrestrial IoT communication I'm telling. Network layer, data link layer, and the physical layers. The class comparison of technology and mostly key. This is where I'm transferring to the satellite IoT. So wh- the key the why you are using satellite means one is coverage. Coverage is very high, and the cost is if you are sending means there will be beginning there will be cost, but later it will cost there will be no cost in that way. The environment and the bit rate will be very low, as IoT application require very less bit rate. So those are the key choices. Key choices. That data type means what type of traffic you want to send, like whether you want to just short message services or periodic message. uh, then the multimedia is very difficult in the IoT. Then the throughput versus range. So you can see that Bluetooth, Wi-Fi, Zigbee, cellular 5G, and the range, cellular 4G, cellular 2G, 3G, LTE. Then satellite. This the at the end it is the at the end there is some sound.
It was from my machine. Sorry, I'll
Okay.
mute.
Okay. Satellite, you can see the satellite range of satellite is on thousands of kilometers. So this is the left side. Right side is telling about the in a quantified manner, like what is the data rate, what is the range, what is the power uses, cost, and frequency of different technologies. So mostly we are in the satellite, we are concentrating on Sigfox and the LoRa. So here it is shown that the range is 1 to 3 miles. Sequence is several miles. In the terrestrial, where there will be lots of obstacles will be there. But when it's come to the satellite, there will be line of sight. There is no obstacles. So there people have tested that LoRa. Sigfox I'm not aware of, but LoRa they have tested. Uh, and they have sent a balloon in the Switzerland, I think. They have sent a balloon where they have tested the 700. LoRa can transfer up to 700 kilometers. Uh, so so LoRa can be used, and in one of project I'm working on, there we are using LoRa as a communication module. Uh, that I'll talk later. Here one animation I'm telling. The epics the project I got the grant for a project that is called epics in IEEE engineering project in community service. There we have proposed a project which is based on to provide information access to the remote area, remote regions. We have considered Kerala, that Kerala has so many mountainous regions. So we have selected some location where there are no cellular communication, terrestrial communication. There, there, and we are building a satellite, a small CubeSat. Uh, there we are using LoRa as a radio for communication. Uh, and LoRa data rate is very low, so that's why it will be short message service communications. That in animation, like if a farmer is there in the very remote area and some machine didn't work, uh, so what happens? He goes to the village office or nearby office. There he gave a complaint. I'm talking about the uh, talking about a case where there will be no communication available. So you'll go to village office, then the complaint will go to the urban area for that machine vendor, and they will come. So it will take time. It will take so many time to register a complaint. When they will come to repair, that will also mm, many times will take. Now, if you have a satellite, that's what we propose. That if you have a CubeSat, a very small CubeSat is our CubeSat is like one U structure. One U called 10 centimeter by 10 centimeter by 10 centimeter. That is the CubeSat structure. In that we have put a computational module that is called Raspberry Pi. So all whatever we are using, it is costs like commercial available components. The market you will find a Raspberry Pi in the market. LoRa you will find in market. Those are not space grade component. So using that, I think around without solar cell, because solar cell is very high price. So except solar cell, the satellite cost around 40 to 50,000. That in that way we have built. Now, it is not yet launched. Maybe this year or next year it will launch. So what is now if you have a satellite in above, and we have developed a user equipment also. User equipment will be around two to 3,000 rupee. That farmer will be having that user equipment. So they will if when the satellite will be in the range, farmer will send a request. The request will directly go to the ground station, from ground station to the urban area. Then if it is a person is required to repair, then person will come. Or or they can, if it is person is not required, if you want to some modification, only farmer can do by themselves, then the only instruction will come. So that will be very less time. So in that way, it will be very helpful for the remote area peoples. Now the requirement of satellite. This is the basic idea for our project I told. Now the requirement of satellite communication in IoT. As this is the advantage of satellite communication, like high mobility. Uh, High mobility. I'm talking about users, not the satellite. Will be in the high, always in dynamic. The satellite network is a dynamic network. I'm talking about user mobility. Then global coverage, high throughput. This is the LEO satellite communication. Then the high range, bi-directional communication, real time communication, low cost connectivity, and low power consumption. So those are the advantages of satellite communication. Yeah, then this is the Iridium satellite constellation. Constellation. The application will be very wide. You can see that application like government, and all those are the customer of the Iridium constellation, like government, security, military, relief, uh, counter insurgency. This is about government, maritime, like shipping, fishing, boating, where it is remote area communication. Then remote and more higher remote industries like oil or gas, mining, forest. Then the aeronautical general, then private, corporate, commercial. Those are the customers of the Iridium constellation, and you can see that most of them are the IoT. It is in the area of IoT, like shipping, fishing, boating, forest, mining, oil, gas. Those are the IoT. Here. So Iridium constellation is consisted of 66 satellites, and and it's like one satellite will be connected with the nearby four satellites. Like each satellite, if you see that, they will be connected to nearby four satellite. In that way, they establish a network. Each satellite footprint is coverage. Satellite coverage is to 2,800 miles in diameters. Very high coverage. They used to obviously they use frequency reuse and multi beam. Like each satellite has 48 spot beams. So now now between the spot beams there will be handovers. Like when the beam is moving from one place to another place, there will be handover, and that is called beam handover, and there will call satellite handover. When the new satellite is coming, then the information will go to the new the all the see for the seamless connectivity. The handover information will go to the next satellite. That is called satellite handover. Now the size of spot beam is 250 miles in diameter. All spot beams are on a satellite overlap. That I already told. Commercial status. Now now this is there are different ground stations are there. One commercial gateway provides global connectivity, which is in Arizona. Then the DoD gateway in Hawaii supports US government traffic. Those are the I already told 66 fully operational satellites, 12 in orbit spheres. Constellation life to 2013 2014 it started at that time. uh, they started Constellation in this year. Satellite operation. Uh, Two places are there where their control center is exist. All gateway supports voice and data service. Dial-up, like you can call through a Iridium satellite constellation. Direct internet access. The speed will be low. Data rate will be low, but you can use like um, uh, flight. In the flight they use when you are get some flights provide Wi-Fi to the customers. They use satellite internet. They can use Iridium. They can use other like geostationary satellite also. Short message services and short burst messages. Though those are for the very remote area communication. Paging, like one-sided communication. If a emergency disaster response are there, so only one way communication will be there from satellite to user to indicate about the disaster upcoming disasters or emergency like forest fire, all those things. Then Rudix is for the customers like special customer who need high data rate. They need to they need to transmit multimedia messages, and though for them these Rudix. This is already discussed. Primary customer segments, ADM network performance. And one thing I told before that in the IoT, the reliability is a issue. Now you can see that in the Iridium network performance, voice and data, for the voice and data, and 99.2% call success rate, 0.6% is call drop rate. For short burst data service, 99.6 for fast data message success rate. So you can see that very high satellite communication can be very highly reliable. It is not always true, but in this case it is true. So in that way, as the IoT uses very short packets, so it can be reliable. Then the another satellite constellation is it is a geo satellite constellation, Inmarsat Orchestra technology. So I will play video now. It is not playable, so I just want to play video. So here I already discussed that in this video. I think here, sorry. Here I already discussed that there are 13 geo satellites are there, and then two highly elliptical satellites are there for the polar region. In the beginning, I discussed. It is used for the global, like it is used carbon communication. Then LEO is for the future. They are sending future satellites, LEO satellites. It can be used in the 5G. They are launching 6 more satellites in 2025. I told that these two satellite for the Arctic regions. And then small satellite constellation they are proposing. They have not sent yet. They are proposed to, and it is a dynamic mesh. Using those satellite constellation, they create a dynamic mesh around different vessels or remote region ships. So they create a network, dynamic mesh network, which will be very much helpful for the communication. And the data rate is very high.
So in the remote areas, even the ships use satellite communication.
Yes, yes. You can see that the plane also there. It is used.
Plane cannot provide
Yes.
to every user. It can provide to only those
Yeah,
specialized
yeah,
users,
yes,
right?
yes,
Hmm.
yes, yes, yes. They have to pay.
Hmm.
This is this is this is simulation. But
Yes, yes. So
go
this
to next.
orchestra is that company which has sponsored.
Uh, yes, this is the orchestra is a company, British company. Not orchestra is a they called it orchestra like for a dynamic mesh connectivity. The name is an orchestra. The company name is Inmarsat. It is
Okay.
collaboration with the VSAT, I think one American
Okay.
company.
Okay.
What
Okay.
I'm not recalling it, but it can say. So this is the two established constellations. Uh, One is there are multiple satellite IoT startup came into pictures like Victor, Comsat, Kepler Communication. Those are the total funding, and those are the in the area which area they are like antenna developers, nano satellite startups, other innovatives like AI, machine learning, or quantum communication, blockchains. Those are the other innovative companies. They work on those things. So antenna is one of the key parameter for the to establish the communication between satellite and uh, IoT sensor. So that's why lots of companies are working on those areas. The nano satellite startup, nano satellite is I told already that is a CubeSats. There one as in the satellite dimension we called one U, 2U, 3U. One U is 3 centimeter into 3 centimeter, 3 centimeters. So there can be multiple use of a nano satellite can be multiple use or single use. Then what we do in this IEEE satellite working group. This is the 2022 editions, and we have around 10 groups and 60 satellite roadmap topics. Uh, According to topics, we have separated the groups like application scenario, reference architecture, uh, in a new MIMO-based physical layer, antenna design, machine learning and artificial intelligence, edge computing, QoS or QA, security, network management, and standardization. I work on the reference architecture group where we are developing architectures, and that architecture will be the base for all other applications in that way. So this is the table of content, and you can see that our architecture team we develop different type of architectures like around 23 case studies where in that case study we used to drone high altitude platforms, low altitude platforms, then LEO, MEO, GEO, HEO also, high elliptical orbit. Those we include all those all those satellites in the architectures. Then there are six for only for the satellite IoT. There are six use cases are discussed. Then using by combining all the use cases, we proposed three reference architectures. Reference architectures one, non-virtualized 5G satellite network. Then reference architecture two, separately virtualized 5G satellite networks, integrated virtualized 5G or 6G satellite network. Now, what the the aim of the map is we are predicting the 10-year. Now, whatever the technological change will happen in the 5-year term, 10-year term, and with present scenario. So in that way, we will will predict. Then and I will provide some research problems so that people will work on those research problems, and those are the contributors, and I think recently they have other contributors are also added, and you can see that it is all over the world. So this is my name and this is my supervisor name. Then this is the reference architecture one. So here what happens, those are the LEO satellite constellation. Mostly you are considering Leo, and this is reference architecture one is based on is based on the current satellite constellation scenario. Like we are considering that if you want to implement 5G in the current satellite constellation, what are the modification is needed. Now in the 5G, what I mean the 5G, this is the 5G core, 5G or 6G core. There are multiple network functions are there, and whatever the call first, whatever the call connect, it will always go to the core. From the core it will go to the internet or other users. In that way it works, 5G works. Now in the with the current technology, UE to satellite, we cannot provide N1, N2 and N3. There are three protocols interfaces are there, and those three interfaces, one is for as we may if you heard about software defined network, one is control plane, data plane, then another is for signaling. So there are N1, N2, N3. Those are always communication between UE and the G node B, that is the tower. So those three are mandatory. Those tower or core network, those connections will be mandatory. For that, we now with current we don't have three interfaces. That's why we proposed a single interface S1, which will take all three datas, N1, N2, N3 datas in an IP tunnel. And the after going to satellite will go satellite to from satellite it will go to the gateway through the another interface. And if they are communicating between satellite, the other interfaces also it will be used. From gateway it will go to the internet with router or switches. From that it will go to the control plane or data plane, control plane. Then from control plane to it will go to the data network. DN is the internet. It will go to data network or user plane. From UPF it will go to other user. So in that way, this is the present scenario, reference architecture one. The reference architecture two is in the 5-year term, with a new satellite constellation being proposed, and they have the uh, onboard processing ability. Usually, whatever recently from here to previous, whatever the satellite there in the sky, most of them are the router. They act as a router. They will just broadcast the data. Neither it will they will they'll receive the data and they will forward to the some other node, networking node. They will not process the data in the satellite. But with the newer satellite constellation, they are proposing to process the data in the satellite. So that's why when those things are possible, then two there will be two control planes. One is for the terrestrial 5G control plane. Another will be the satellite control plane, which will be for the satellite. Then then this is the all the networking functions are same, except that we have introduced two functions. It's called satellite federation function, another called satellite aids function. Now what it will do, and satellite aids function is the same, similar to the satellite sorry, mobile aids computing, MEC, the terrestrial. It will just cast the when the use when in an area, when the multiple users are requesting a single file or single video, it will just it will cast that file or video in the node nearby, G node B or E node B, and that is the cell tower. Then when the next time the users will request from the cell tower, it will come. That is concept of the edge computing. There are many more in-depth in-depth is there. I'm not going in that detail. So similar to that mobile edge computing, we introduce the satellite edge computing, or satellite edge functions. And then another function you introduce is federation function. Like now multiple satellite constellation are proposed in the satellite, like Amazon is proposed, Starlink is proposed, then Airtel and Telesat, they have collaborated and they have proposed another satellite constellation. OneWeb is another one. Multiple satellite constellation, and whole sky is like full of satellites in the future. So now what happens, uh, they need to collaborate with each other, for to help each other. They need to collaborate. That's where the concept of federation is coming. So like if I have a free resources, like I have a free buffer or free memory or free bandwidth, and other company or other organizations, they require those things so that they can use this satellite also. So for that the protocol is needed, some protocols is needed, some rules or regulations are needed. For that we have introduced one function, that is called SNF. Now other things are, it will be all are similar. The S1 interface will take the N1, N2, N3 data and informations. Then other things are same. Now this is the third one. This is the 10-year. In the 10-year time, uh, 10-year time, the here in this another difference is that the synchronization is needed for terrestrial control plane and satellite control plane. The synchronization is needed. That's why the one M1 interface is needed. Network function virtualization or MANO for both. This is the controller of the MANO is the controller of the network functions. All the network functions. This is the controller. So both controllers should be synchronized. That's where, but in the 10-year case, that is not required. There might be possibility that both terrestrial or and satellite, they are using single integrated 60 satellite control plane, and it can be placed in the satellite or it can be placed in the ground also. That depend. And we have, and then the other non-terrestrial elements like HAP, high altitude platform, drones, UAV, balloons, other non-terrestrial network element will come into the picture and at those times for the lower delay. And those things are come into picture because as we know that Leo has orbit of mostly 450, 300 is minimum. Below that the gravity will be drag the satellite. It will in some days it will come down to the Earth atmosphere. Now, if you are considering 60 delay requirement is 100 microsecond. Now, if you are considering imagine that 300 kilometer altitude, the propagation delay is only propagation delay is 1 millisecond, and round trip propagation delay will be 2 millisecond. If you are considering the other like processing delay, transmission delay, then delay will be higher, like 4 to 5 millisecond. That will be the minimum for the LEO for a 300 kilometer orbit. For the 60, you require 100 microseconds. So the LEO is not enough for the 60 satellite 60 communications. So that the other things are introduced like drones, UAV, balloons, which will be helping LEO to achieve that delay. That's why this is called non-terrestrial element (NTN). Now those things are introduced in the 10-year time. That is that is the that these things are come in the recent version of our of our working group report. And all those things are use applications are in this area, like vertical, healthcare, autonomous car, manufacturing, precision agriculture, education, smart infrastructure, non-terrestrial networks, smart cities, space-based hosting service, satellite-based IoT service. All those are the application of the of our reference architecture group. And you can see that this is the drivers and enablers listed out. So many of our working group members are working on those things, and they proposed all those things, and all are and many of the applications are on IoT. They need sensors, they need communication, machine to machine communication. Those all are the use cases. For the research possibility, uh, those are the area which is not explored that much, like blockchain and quantum communications. And one company called Leo Constellation, they use WP1. This is I think LP1. This is spelling mistake. And the LoRa for the IoT application. They used both these things for the IoT application, and they use blockchain based. They used blockchain in the satellite constellation. Then QubitSat. They use blockchain integrated satellite network with the quantum communication. It is not fully developed. It is a startup. Those are the startup companies. Then machine learning can be used to in the satellite network, like neural network for high reliability and quality of service delivery. So we can check the history of the, like, for routing, for if you can predict the loss. Loss is the main factor for the satellite communication. One is free path propagation loss, which will be always there. That is depend on the distance. And the other is the what you call atmospheric loss, like atmospheric, like rain and cloud, and other some elements reflect, they absorb the information in the higher and the high when you go to higher and higher frequency. Some elements in the atmosphere, they absorb the information. So those loss, if you can predict those losses, that will be very helpful for the routing, for better routing. That's where the neural network comes. Then deep learning can be satellite position determination, for exact satellite position determination. Actually, many simulators, they used already they use deep learning. Like one simulator I'm using STK, which will predict the satellite positions very accurately. So already the people are used. Then fault detection ML algorithms to improve long-term performances. Satellite can when the satellite goes to space, that is not on our control. After that, it is not on our control. So some fault prediction mechanism should be there, so that, like, so that it will automatically reboot or restart, or some of the things it can do uh, to improve the long-term performances. Like if the radiation is coming, it should shut down. It shouldn't active at that time. After radiation is over, it can active, because many components are being damaged due to radiation. So they don't know when we don't know when the radiation will come. Then AI for the better routing. So this is the artificial intelligence for the better routing. I think this is the talk my supervisor is giving later of the day about AI. And this is the, like, one type of conclusion. This is a nice diagram. So sorry, this is for this figure IoT heterogeneous network architecture. Now in this case, the satellite can be directly connected to the IoT devices, IoT repeater or IoT devices. That is called LEO satellite, dense or spare constellation, that depend on that is user requirement. Inter-satellite link, they can communicate in between LEO to LEO, or LEO to GEO, or LEO to MEO. That is one type of things. Then another will be indirect to satellite IoT, like through cellular, IoT device will be connected to a cellular network. A cellular network will be connected to a LEO satellite. In that way, it is possible. Then there will be there will be Wi-Fi access point where the IoT device will be you. They will connect to the Wi-Fi access point. Wi-Fi access point. There might be like Starlink use one ground station antenna. So in that way, it will connected to the ground station antenna. Then it will forward the request to the geo satellite. In that way, that is the indirect to satellite IoT. Then those things will go to the application server and network service core. Then in that the decision will be made. Then it will go to the user equipments. That is what that it is direct to satellite or satellite as a backhaul network. Usually in the recent satellite constellation, that one point I missed it, that the satellite is in the 5G, mostly in the 5G communication, the satellite uses as a backhaul network. It is not act as a service delivery. It is act as a backhaul network. As it has only routing capability, it don't have processing capability. So it uses as a backhaul, like from from user to the E node B or G node B or G node B. When it go to G node B to the core network, it might use satellite, or user to G node B, it might use satellite in between. If the distance between E node B and G node B, like a user is here, for example, user is here and cell tower is here, so there is no range is there, so that it can directly go to satellite. From satellite, it will go to the cell tower. In that way, that is a backhaul service. That's how the recent constellation are being used in the 5G. Then this is the terrestrial network. Cell band networks as NB-IoT and narrowband IoT LT coverage is 340 square kilometer. Or low power wide area network like LoRa, Sigfox, the coverage is 5025 square kilometer. That's why LoRa and satellite are proposed to be used in the satellite for the IoT communication. Then the Wi-Fi network, sensor network, those are for the IoT node, IoT devices ground. They can use Bluetooth and Zigbee. They can use LoRa and Sigfox also. In any protocol they can use technology. So this is my presentation. Thank you.